In today's video, I will be solving a problem based on inference line diagram. So, this is the question. A simply supported beam of span 10 meter is shown in the figure here, okay? And here, determine support, reaction, shear force and bending moment at point C using the inference line diagram method. So, we have to find the reaction, shear force and bending moment at this point, C point, okay? So this is the question. Now in my previous video I have already mentioned how to draw the IL for RA and IL for RB. IL is nothing but the inference line, so I'll directly draw here, okay? And if you want, you can go and check my previous videos so that you'll be clear about how to draw the inference line diagram for RA and inference line diagram for RB. So here this is the this is the inference line IL for RA, okay? Now I'll draw inference line for RB. It was straight here, up, sorry, this one, and I have to draw like this, okay? And this one is for IL for RB, okay? Now next is what we have to do here. See, at C point we have to find the reaction. Now at point C we have to draw the reaction, shear force and the bending moment, okay? So you have to draw like this, and this is the point C. Now again we have to draw a projection here at this point where the point load is acting. Now for IL for RA we have to find X value, this value and for this value, okay? And for IL for RB also we have to find this where the load is acting, okay? So now it was A, I'll write down, and it was B, right? A and B. Now we will find for the IL for RA now, okay? So I'll write here IL for RA. IL for RA. So we'll find these values from a similar triangle method. So I'll write from a similar triangle method. So in my previous video also I have already mentioned about the similar triangle method. That is nothing but this is the whole triangle, right? This one was 1. So the area at this one, the whole triangle is equal to this triangle, so that we can get the value of X, okay? So now here and I'll redraw, okay? So this was for RA and we have to find this one and this one. This one was X1, this one was X2, this one, and the distance is 6, 2 and 2. Now we'll find for this value. So from a similar triangle we'll get this value, that is the big triangle is 1 by the whole distance is 10, right? 6 plus 2 plus 2 is equal to this small triangle, this triangle, that is X by, from here to here distance is 4. So now from here we'll get the value, that is X is equal to 0.4. Now again we are finding for this value, this is 0.4. Now we'll find for this value, that is 1 by 10, the big triangle is 10, is equal to X by this value 2, okay? 2. So here X is equal to 0.2. Now I'll highlight this value and this value. This value is 0.2 and one value is 0.4. Again we'll draw for a IL for RB, okay? Now IL for RB. So if we are finding for RB, then we have to look for this diagram only, and when we are finding for the RA, we have to look at this diagram. So now we will be solving for this. Again, I'll draw here. Okay, this was like this, right? And we have to find for this as well as this. It's A and B. Now we have to find for these values. So again, from a similar triangle, we'll find it will be opposite of that. No, sorry. So it will be 1 by 10, this big triangle, and the small triangle is from, see, this is a big triangle, 1 by, this one whole distance was 10, okay, is equal to this one was x divided by this distance was 6, right, and this one is 2, so total is 8. So here x is equal to 0.8. So here the value of x will be 0.8. Now again we have to find for this, and it will be 1 by 10 is equal to x by this distance is 6. So x is equal to 0.6. Okay, so these are the ordinate points of RA as well as for RB. Now we have to find the reaction. In the question what it says that we have to determine the support reaction, shear force as well as bending moment at point C, right? So now we'll solve for the RA, solving for RA. Okay, I'll write like this. Now for RA, what we'll do, okay, I'll redraw the diagram. RA diagram was like this, right? And here one loading, and the distance was 10 meter, and this is 6 meter, and this is 2 and 2 meter. And we have already the value of this was 0.4 and 0.2. It's 0.4 and it's 0.2. Okay, now this is 1, right? So now what we have to do, this one was A and this is B. So we are finding for RA and RB here. So here RA is equal to, see, in my previous videos it was all about the point load, but in this problem here one UDL is there. So for the point load, what we had done was, for the point load we have to take the load, load into the ordinates, right? But in case of the UDL, what we have to do, we have to assume the load into the area, okay, in case of UDL and in case of point load. This is important thing which you have to remember, okay? Now let's start. So finding the value of RA, what is there? First, okay, here I'll draw the diagram also. It was like this, okay, and up to the C point, this is C point, right? C point UDL is there, and for this one point load is there. UDL of what was there, 30, and this one was for 50 kilometer. Now for finding the RA value, what will be there? This the load, 30 into, now in case of the UDL, what we have to do, we have to multiply it with the area. So we'll take out this and this, and this is the trapezoidal shape, right? So here it's 1 and 0.4, and the distance was 6, right? So here what is the formula for trapezoidal? Here E plus B whole divided by 2 into the height. So let's solve this one first. E is equal to A. Let's assume this as A and this as B, and this is the height, okay? So 1 plus 0.4 divided by 2 into 6, then we'll get, no, I'll directly write it like this, okay? So this is the formula. Now what we have to do here, we have to multiply the area here, that is 1 plus 1 plus 0.4 divided by 2 into 6 plus again, see here, this is 50, right? 50, and it's a point load. So in case of point load, we have to take the ordinates. So ordinate is nothing but 0.2, that is 50 into 0.2, and when we'll simplify this, we'll get the value around 136 kilonewton meter. Now we have to find for RV value. Okay, so for finding the RV value, see, this is the, I have to redraw the diagram here. I'll draw here. Okay, so this was the diagram, and we have the value of here, that is 0.8 and 0.6, right? So now it's A and B, and this is point C. Now we have to take RV value. So this was the question, and from here to here UDL is there, and here is point load A and B. Now in case of the UDL, what we have to do, we have to take the area, right? That will be 30 into this area, right? This area, it's a shape of a triangle. So what was the formula? Half into base into height, right? Half into base into height. So just you need to put the values. Half into base will be 6, right? 6 into height is 0.6 plus, this is, here it was 50, right? 50 into the ordinates, so 50 into 0.8. So we will get the value around 94 kilonewton meter. This is the value for RB. Now we have a value for RA, that is 136 kilonewton meter, as well as we have a value for RB, that is 94 kilonewton meter. Now next is to calculate for shear force at point C. Okay, sorry, now we have to now we have to calculate for shear force at point C. So let's draw the diagram here, and this diagram has, and for the shear force, how the diagram will be, and I have explained this diagram in my previous lecture also, so you can go and check it out. So it was like this. Okay, sorry. Okay, we'll try to go like this. So diagram was okay. So diagram was like this. Now the question was, I'll draw the question also here, and from this point to this point, one was UDL was there, and this is the C point, and up to C point 1 UDL was there, and it's A and B, it's of 50 kilonewton and the UDL of 30, and from this E to C 6 meter distance was there, and from here to here 2 meter and 2 meter, right? Now so 2 meter by 2 meter. Now we have to draw the projection here, and for this is projection here, right? So here this is, now we have already the value of C here. C, that is, one was 0.6 and one is 0.4. So 0.4 in case of the RA, here is 0.4 and this is 0.6. Okay, now we have to find for this projection. Let's assume it as X. So now again from a similar triangle we have to find this. So I'll write like this: from similar triangle Now this big triangle, right, this is the big triangle, that is 0.4 divided by 2 meter and 2 meter, that is 4, is equal to x divided by this 2 meter, right, 2 meter, then x value will be 0.2. okay, so now we have to find for shear force at C, that is shear force at C from this one. So now shear force at C will be, okay, here from, we'll start from here, that is 30 into we have to take the this area into triangle, that is the formula is half into the distance is 6 meter, right, so here is 6 meter, 6 into it's downward, then it will be minus 0.6 plus this is the ordinate, so we have to take the load and this value is nothing but 0.2, so 50 into 0.2, 50 into 0.2. So in case of the UDL, we have to take the, here UDL was acting, right, so we have to take the area of this triangle where the point load is acting, we have to take the ordinates only. Okay, so after solving this, we will get the value around minus 44 kilonewton. So now we have a value for shear force at C also. Okay, this is the value, that is minus 44 kilonewton. Now we have to calculate for bending moment at point C. So write like this: calculation for bending moment at point C. Okay, now again I have to redraw the diagram here, that is, it was like this. So this is RA and RB, and one point load was there, and from here one UDL was acting. This is A and this is B and this is C. Okay, so now the distance is from here to here is 6 meter, and it's 2 meter, and it's also 2 meter. Now we have a value of RA is equal to and RB. Okay, this is RA and RB. Now is equal to something. What was the value of RA here? RA was RA was 136 and RB is 94. 136 and 94, right? Here 136 and 94. So it was 50 and this one was 30. Now the bending moment diagram for this one will be like this, and we are finding for C, right? So finding for C, the maximum value will be at C. So this one also I have explained you in my previous lecture, so go through it once, okay, so that you will be clear about how to draw the bending moment, shear force, and the IL for RA as well as for RB. So now at this peak point, what will be the formula? L minus A divided by L into A. So let's find for this one. Okay, so see, from here to here we assume it's a A, and L is nothing but the total length, so is equal to L is the total length, that is 10 minus A is 6, right? 6 divided by 10 into 6, so we'll get the value around 2.4 meter. Sorry, it's not a meter, so it's 10.4 kilonewton. Okay, so now we have a value. So now here for the point load we have to draw the projection here and this point. Okay, X, let's assume it as X. So we have to find for the X value. Again we have to apply the similar triangle formula. Okay, similar triangle. From the similar triangle we can find the value of x. Okay, so this is the big triangle, right? Big triangle is nothing but what was the value? 2.4. so 2.4 divided by the whole area, that is 4 meter. 4 is equal to x. X is unknown to us, and from x to here b distance is 2, so we can get the value of x from this, that is 1.2. now after getting this, we can easily find the bending moment at C. Now let's find for bending moment at C is equal to 30. See, this 30 into this area, so 30 into area is half, into base is nothing but 6, into height is, this height is 2.4 plus 50 point load, this is 50, right? 50 into the ordinates is nothing but x is equal to 1.2, that is 1.2. so after simplifying this, we'll get the value around 276 kilo Newton meter. That is the bending moment at C. Okay, so here we have all the values with us. That is the reaction. First one was to find the reaction. Reaction is nothing but the RA value and the RV value. And next is to calculate for the shear force at point C. Okay, so this is the value for shear force at point C, that is nothing but minus 44 kilo Newton. And the third one is to calculate the bending moment at point C, and this is the value of bending moment at point C. Okay, thank you.